Well, hello everyone. My name is John Tillotson. I'm a Technical Business Director at ABITEC Corporation and excited to present today on two relatively new products to our company, the ABISOL Emulsion Preconcentrate Kit, which we'll talk about first, and ABISORB-DC, a co-processed excipient for the direct compression of liquid lipids. So I will just get right into it. We're going to discuss first the ABISOL Emulsion Preconcentrate Kit. And basically the kit was designed out of our experience with developing pre-concentrates for customers. So oftentimes it's a lot of work and empirical efforts in the laboratory to develop a pre-concentrate for a self-emulsifying drug delivery system. And many pharmaceutical companies don't have experience with lipid-based drug delivery and self-emulsifying systems. It's also impractical to screen for multiple compounds oftentimes. And you don't want to develop a new system for every compound if at all possible. So that was the idea behind developing the system, which is a series of pre-formulated pre-concentrates. The idea of these pre-concentrates was to generate a type 3A or type 3B emulsion. And these emulsions typically are composed of a solubilizer, an emulsifier, and one or more surfactants. We wanted them to have different HLBs or pre-concentrates so that they would dissolve different actives of varying hydrophobicities, either more or less efficiently depending on the pre-concentrate. And we wanted the emulsion globule size to be a type 3A or type 3B emulsion globule size, which is typically under 100 nanometers. What came out of this research was the ABISOL formulation pre-concentrate kit. We had 5 pre-concentrates of differing emulsions, or differing HLBs, and that's the hydrophobic lipophilic balance. We used 2 different surfactants, a high HLB surfactant and a low HLB surfactant, one being an ethoxylated castor oil, which is chloroforol, and one being a linoleal macrogol glyceride, which is Achenon CGMC6. And we used an experimental mixture design to develop these. And the responses we used in the design were the HLB and the emulsion globule size. And these labels 1 through 5 are just arbitrary labels, but the HLBs on them are between 5 and 10 in hydrophobic lipophilic balance. You can see here a study of these preconcentrates diluted 1%, 1 gram and 99 grams of water, and mixed for 2 minutes with a magnetic stir results in a globule size of all preconcentrates, 1 through 5, of under 60 nanometers, so well below the 100 nanometer threshold we were looking for. And it has a very low polydispersity index, meaning the population, the globule population size is small with regard to its actual globule size. So you can see those red dots exhibit that. So all of them are below, or right around 0.1 or below polydispersity. So relatively uniform populations. We did a test here with ibuprofen, and the first step in using this system is to do a solubility screening study in each pre-concentrate. So in pre-concentrate number 5, ibuprofen dissolved much more readily, and so that was the pre-concentrate of choice for this molecule. And what you'll find is this type of empirical analysis is the best way to determine which pre-concentrate you would want to use in your self-emulsifying drug delivery system. Subsequently, looking at the globule size of the ibuprofen dissolved in preconcentrate 5 when added to water in a 1% to 99% water ratio, it stayed below the 100 nanometer threshold, making a nanoemulsion of 56.03 nanometers, which is what we would want. And this, any drug can be analyzed this way. This ibuprofen was just chosen as a test model drug, but you could screen any type of active you'd like through the kit and determine which emulsion preconcentrate 1 through 5 would be best for formulating a self-emulsifying drug delivery system with your particular active ingredient. So what do you get in the ABISOL kit? Obviously, we have a safety data sheet, a technical data sheet. There's a brochure we have on it. You can see a PDF of it there. A C of A, API solubility maximum tolerated dose. And you can inquire with us at abiteccorp.com if you're interested in purchasing one of these kits and in analyzing your molecule for a self-emulsifying drug delivery system. The second new product is ABISORB-DC, and this is a direct compression excipient system for liquid lipids, where you can tablet liquid lipids in typical tableting processes. So why were we interested in doing this? Well, for a long time, our liquid excipients were used in self-emulsifying drug delivery systems or singular lipid active dissolving systems in soft gel capsules or in liquid-filled hard gel capsules because liquids are difficult to tablet. However, as you can see from some pharmaceutical data, the oral dosage form is the most common, and greater than 75% of these are tablets. So we wanted to have a way of putting our liquid lipids and self-emulsifying drug delivery systems into tablets. And the result of that was the ABISORB-DC excipient system. So what are the advantages of some of the tablets over capsules? They're more cost effective. They have a higher rate of manufacture. Typically, you can do higher dosage, increased manufacturing options, increased stability, easier to generate modified release. You can make custom size, shapes, and appearances. You can put a score in the tablet so it can be split. And you can make different types. Chewable, orally dissolving, paraoral tablets are all possible. But the issues with tableting lipids or liquid lipids is that one, oftentimes the lipid was not well absorbed by typical tableting excipients such as microcrystalline cellulose or lactose. Calcium sometimes doesn't absorb it as well, and it can cause a smearing or spreading over the surface of the excipient, leading to a mottled tablet appearance, especially when you're using colors. Liquid lipids interfere with bonding, resulting in low hardness, high friability tablets that have tablet defects. And you can see in the pictures there some tablets that we initially studied, not with this system, but with other systems we tried to develop. And they resulted in high friability tablets. And liquid lipids can often cause sticking to the tablet press. And this is especially common in what I would call inorganic type excipients like calcium silicate, which absorbs oil but can stick to the press quite readily. Dibasic calcium phosphate is another one that functions that way. We didn't want any of these things to happen. An incomplete release of the active is often a problem when tableting liquid excipients. So what was our quality target product profile for developing ABISORB-DC? We wanted to maximize lipid carrying capacity. We wanted it composed of compendial ingredients so you don't have difficulty registering the product. We wanted it to manufacture robust tablets, high hardness, low friability, without tablet defects, no sticking to the punches, die walls, or die table. We don't want any externalization of the liquid system. The SEDs preconcentrate upon compaction. Full release of the active, so we don't want it held up inside the excipients, and no specialized equipment required. We didn't want you to have to buy like high melt extrusion type of apparatus or spray dryer or congealer. We just wanted this run on standardized tableting equipment, and manufacturing possible at industry speeds. In other words, we don't want you to have to slow down the press that much to run it. We want you to be able to run it on a rotary press. So what resulted from this is the ABISORB-DC excipient system. And what is ABISORB-DC? Well, it's a free-flowing co-process system of that can absorb lipids and then directly compress them. It can carry 20 to 25% weight by weight of lipids. It can carry either neat lipids or a combination of lipids to make a self-emulsifying drug delivery system. It's manufacturable on industry standard tableting equipment. It's manufacturable at industry tableting speeds below 12 milliseconds of dwell time on the tablet press. It makes robust tablets without any sticking to the die walls or the punches. And it releases the active during dissolution. So it met our quality target product profile. What are the advantages of this type of system? Well, you can combine lipid-based drug delivery and the bioavailability enhancing features of that type of drug delivery with the ease and speed and throughput of manufacturing of direct compression tableting. You can increase the solubility and permeability of BCS class 2, 3, and 4 actives. You can improve the content uniformity of low-dose APIs, just like a wet granulation would. This liquid system allows you to spray a liquid in with the API dissolved, which improves content uniformity. You can improve the safety and handling of certain APIs because once they're dissolved to the preconcentrate, they can no longer aerosolize. And protection of sensitive actives in the GI tract inside the micellar system that forms upon contact with water. So there's a SEM of ABISORB-DC. You can see a relatively round morphology, which allows it to be relatively free-flowing and functional on the tablet press. ABISORB-DC physical characteristics. The most important here is the surface area. It has a high degree of surface area for absorbing liquid lipids. and the Carney flow has a relatively good flow. The density is also important. ABISORB-DC tends to be denser than other single or Unitarian oil absorbers like calcium silicate, dibasic calcium phosphate, just colloidal silicas. It's denser than that, so it's easier to handle. The average particle size is 53 microns. And so let's take a look at how you manufacture with ABISORB-DC. It's very easy. It's a 4-step process. You make a preconcentrate of the drug dissolved into your liquid lipids. You spray on that preconcentrate in a high shear granulator. Then you blend that ingredient with in any type of blender you want. In this case, we have a double cone blender, or we have a V blender, and then you can compact on your tablet press at industry level tablet speeds. So this is a relatively easy 4-step unit operation process, and you can see these are all typical pieces of equipment found in almost any tableting facility. So no specialized equipment necessary. Here I have a video of the process where we used ibuprofen as a model drug. And so as I stated, here we are starting our pre-concentrate, and we're weighing out Captex, the solubilizer. We're adding a Capmol monodiglyceride as the emulsifier. And then we're adding a polyoxyl 35 castor oil as a surfactant. We blend these together to make the pre-concentrate uniform. Then we weigh out our active, in this case ibuprofen as a model active. We dissolve the ibuprofen inside the pre-concentrate until it's completely dissolved. And this took, I think, about 15 or 20 minutes. You weigh out your pre-concentrate in order to generate the dose you want in your tablet. You weigh out the ABISORB-DC. You add the ABISORB-DC to a high shear granulator. And subsequently, in this case, we used an airless sprayer, but you could use a atomized air pressure sprayer and a peristaltic pump. And we spray the pre-concentrate onto the ABISORB-DC. It comes out completely absorbed onto the ABISORB-DC, and then we blend that in any type of pharmaceutical blending equipment you care to do it in until that's uniform, and then you just compact at industry tableting speeds on a rotary tablet press. So this is a SEDS ibuprofen tablet that we've generated here. So I just want to talk a little bit about the compaction. We tested the compaction limits and oil absorption limits of ABISORB-DC, and we used Captex 8000 to do this. Captex 8000 is a fairly oily medium chain triglyceride, fully substituted glycerol molecule. And what we did is we ran it on a Manistee beta press, and we wanted to look and see how press speed and tablet compression force affected the tablet hardness, because we wanted to see how press insensitive the actual ABISORB-DC was in terms of press speed and sensitivity. So we used a design of experiments to do that. And in this first case, this is just a placebo. There's no Captex 8000 added. And you can see when we look here, we can see 92% of the hardness of the tablet is generated by compression force. Almost none is affected by the press speed. And if we look at the friability table on the bottom right, you can see that we can generate low friable tablets at all press speed studies, 30, 45, and 60 RPMs of rotation, and all compression forces, 8, 12, and 16 kilonewtons of compression force. When we add in 5% Captex 8000 as a challenge, we can see that, once again, most of the tablet hardness is due to compression force. And once again, in the friability area, we can generate suitably friable tablets at all press speeds and all press compression forces. We get the same characteristics at 10%. It's press speed insensitive, the material, and we generate at all studied compression forces and press speeds suitable tablets. At 15%, we have the same exact result, very low press speed innervation of the tablet hardness, and we generate suitable tablets at all studied compression forces and press speeds. When we get to the 20%, we can see that now the compression force and the press speed is more important, and the compression force with press speed is also an interacting effect. However, we are able to generate tablets still at 20% at 45 at 45 press speed and 16 kilonewtons of compression force. And there's only 2 areas where the tablets were unsuccessful. So you can still operate relatively easily at a 20% load of the lipid. At 25%, we can see that press speed becomes a predominant characteristic in this study. And so it is no longer press speed insensitive at a 25% oil load. However, controlling the press speed to 8 kilonewtons of compression force and 30 RPM, so slowing the press down a little, you can get very suitable tablets. And this is why we decided that 25% is probably the maximum oil load weight by weight on ABISORB-DC that would be possible. And by oil load, I mean your SEDS preconcentrate. We decided to carry out the study even further and add in the oil challenge or the oil percentage in the system to see how that affected the actual statistics of the hardness of the tablet. As you can see, clearly as you add more oil, the hardness drops. So that's to be expected. The oil is the challenge to the system. So as you add more oil here, the blue line being no oil and the bottom line, the green line being 25% Captex 8000, you can see that the tablet hardness does drop. And when you add that into our system, so we study 3 factors affecting compression force rather than 2. We're studying the compression force, the press speed, and the Captex 8000 load. We find out the material is relatively press speed insensitive. The major contributors are the Captex 8000 level, which is expected as it's the challenge, the compression force, which is what we want to be affecting the tablet hardness, and then the interaction between the 2. So actually, when you add in the oil as a factor in your study, it eliminates press speed as a significant factor. So one of the things about this technology is it's targeted for lower dose drugs. You can see the tablet weight is dependent upon whatever the dose is divided by multiplying the percent API in the preconcentrate that you're able to get into the preconcentrate, the percent API that go, or percent preconcentrate on the ABISORB-DC, and the percent ABISORB-DC in the blend. So when you multiply all those out and divide the dose, that'll give you your tablet weight. So you can see it's very dependent, really, mostly, because you can typically get 20 to 25% preconcentrate on the ABISORB-DC, so that's will be relatively constant. It's how much active you can dissolve in your preconcentrate will be the primary effect on this. We were able in our formulations to get very good tablets at a 77% inclusion of the ABISORB-DC loaded with preconcentrate in the blend. So for instance, if you can only get 5% or let's say 10% here of a dose inside your, or 15% your preconcentrate and 15% of the oil on the ABISORB-DC, you can see for a 10 milligram dose, you need a 576 milligram tablet. For a 40 milligram dose where you get 40% dissolved, and this would be like CBD and Captex 8000 will dissolve 40% weight by weight in the preconcentrate. You can see in 25% load, you can get a 40 milligram dose and a 520 milligram tablet. So this technology is effective, and it is very effective for lower dose drugs. Okay, so a quick case study with loratadine. It's a BCS class 2. It's poorly soluble. It's an antihistamine. And the typical daily dose is 10 milligrams per day. You can see our formulation here. We have loratadine 10 milligrams. We dissolved it in ABISOL 2, which is where it had the best solubility, about 10% solubility. We have ABISORB-DC at about 61% here. We have dextrates added to give some flow and some higher density to the formula. And a small amount of sodium stearyl fumarate is a lubricant. And we passed the weight uniformity of both the USP and the EP weight uniformity requirements. Our friability was 0.02% with a disintegration time of 1.53 in this tablet. And you can see our hardnesses and our averages are around 5.5 hardness, 650 milligram tablet. You can see here in this particular instance, we passed content uniformity. Our assay is slightly low. We did repeat this study at a different center and sonicated longer. I don't have the data here, and we got much closer to 100%. I think it was like a 97% assay. So I believe the assay being slightly low here is due to the us not sonicating long enough, but still the product passes content uniformity. 100% was released on dissolution in about 60 minutes. So the entirety of the preconcentrate set up, emulsified, and left the tablet excipients and was available for dissolution testing. And you can see that coming out of the tablet, our globule size is around 100 nanometers, which is right around where we want to be, 100 nanometers or below, for fast dispersibility and quick absorption of the active. We did another case study, which is predominantly a speed study for BCS Class 2 CBD, and we did this in Captex 8000. Typical dose is 25 milligrams per tablet. You can see here we got 25 milligrams into a 540 milligram tablet. We have 4.6% active, 61% ABISORB-DC, once again dextrose. So very simple formula. You don't really, it's not a complicated formula. And you can build up a quick self-emulsifying drug delivery system tablet. We ran this on a rotary press that can run relatively fast, so it was run at 12.2 milliseconds of dwell time to simulate a pharmaceutical tableting run at industry speeds. Okay, so when looking at the weight variation, we only did 10 tablets in this case. However, these tablets all pass both USP and European Pharmacopoeia weight variation for the 10 tablets. We were able to get relatively hard tablets. For a tablet the size 11 is the average of the friability of 0%, so they lost nothing on friability. It's worth mentioning here that as you add liquid lipid to the system, it creates a more plastically deforming mix. So you have very little elastic recovery of the tablet when you release the compression pressure, and this helps lower the friability of tablets manufactured with this technology. And you can see there's virtually no punch sticking. There's no sticking to the punch. It's a very clean situation here. So that's also rare, especially with the inorganic liquid lipid absorbers. So I just want to talk briefly about, there's certain singular excipients out there. There's calcium silicate, there's dibasic calcium phosphate, there's colloidal silicas. What are the advantages of ABISORB-DC over that? Well, it's been balanced for lipid loading and compaction. It's a one-stop shop. It's easy to use because of that. So you have a lot of reduced formulation work. It has a higher bulk density, so it's easier to handle. It flows better than those excipients. There's minimal oil loss on compaction and increased overall compaction compared to most of those excipients. And while single excipients may carry higher oil load as a single excipient, you typically have to add other ingredients, granulate, add unit operations, which tends to lower the oil load of the overall formulation at that point, because there's a lot of work and effort to go into solving the problems like sticking and flow and compactability. So ABISORB-DC is a ready-to-use product and very easily used with self-emulsifying drug delivery systems. So in conclusion, ABISORB-DC is a co-processed excipient system specifically and optimally designed to absorb and directly compress lipids and other oils. It allows for the combination of the bioavailability enhancing features of lipid-based drug delivery with the ease of manufacture and high throughput of direct compression tableting. There's a typical ABISORB-DC loads oils typically at 15 to 20% weight by weight and up to 25%. It's free-flowing and highly compactable, and it's very easy to formulate with a minimum requirement for other excipients in the final formulation. ABISORB-DC is easy to manufacture on standardized tableting equipment, and lipid formulations loaded on ABISORB-DC can be compacted at industry tableting rates, and they provide for full release of the active ingredient. And with that, I conclude, and I invite you to visit us at www.abiteccorp.com to check out the white paper on ABISORB-DC that describes in more detail the manufacturing process. You can just search for ABISORB-DC on our website. And also, if you would like to contact me, J. Tillotson, Tillotson, at ABITECcorp.com, I'd certainly be willing to provide you a sample or answer any questions you might have about this novel excipient system.